and it's getting reflected. And what is this angle here? I denoted beta. So classically, it doesn't matter, you would think. So you would think that light comes from the direction at angle alpha, so it has to reflect at the same angle, doesn't matter whether the mirror is moving or not. So you would say that beta is equal to alpha. But in relativity, this is not true. Because in relativity, the law of reflection, that those angles are equal, is only valid in the rest frame of the mirror. So if you transform those directions to the rest frame of the mirror, it will turn out that this angle alpha changes. So in the rest frame of the mirror, because the mirror goes this way, let me quickly think which way it's transforming. So it comes at some angle alpha prime, which then gets reflected at the same angle alpha prime. But then when you transform this direction back into this frame, you get a different angle beta, which is not equal to alpha.
Okay, so you're saying that, hold on. In the frame of the mirror, light, in order for it to change direction, there would be a velocity change, okay? So how do you have C not being C all the time in the rest
It
of
is C. It is C here, it is C here, it's only a different direction. Okay,
what would create an angle change then?
Okay, let's do it.
Hold on,
you have...
wait a second. Wait. Before you just, I want a concise answer, but I'm pressed for time. I literally gotta leave in just a couple minutes. It doesn't, if the world around me is moving, right? The whole world is moving around me, but I'm just a little mirror just chilling in stationary, right? Who cares if the world around me is moving? That has no effect on the light that's touching me. Why would the light bounce off at a different angle? What's happening here is there's a physical effect happening. It's a velocity composition, right? The mirror has a velocity, and that carried velocity is being added onto the incoming photons, and that's why it's creating an angle change. The only reason you can't accept that is because it violates the postulates of your theory.
Not quite. It's still basically this law of equal angles is still preserved in the mirror's frame, but it turns out that if it is preserved in the mirror's frame, it cannot be preserved in the frame in which the mirror is moving, because if you transform those directions, you can just see what the velocity vector of light here is, transform it to this frame, reflect this component, transform it back to this frame, and then... So actually, now that I think about it, I'm not sure if this is correct in such a setup, but it's definitely correct in a setup in which the mirror is at an angle.
So can you give a formula? Let's make this concise. Can you give me one formula that will universally and correctly predict aberration for all objects? Now, light, of course, is one particular object, but it's simply just a physical effect that we're measuring. It's a ratio of velocities. It's a horizontal shift versus a vertical component. So can you give me, because the only formula that I have is a trig function. It's just trigonometry. It's tangent theta equals v over c, or you could say v over g, right? G equals c in this case. But tangent theta equals v over g. I could use that to predict aberration in any system, anywhere. It's valid for any other system I point it to. In this case, if you use two different g values, how could you possibly have the same angle? I just want you to give me one formula that correctly predicts both results with different g values.
So I have to derive it actually, and if we are pressed for time, it's going to get complicated.
Yeah, that was the purpose of having you come on. So if you still have time, I'll keep the recording going, and you can math it out for us, and we can come back to it or something at the end.
All right. Yeah, I should still have some time. I can just quickly do this transformation, and then we'll see what happens. All right, anyway.
Yeah, so, well, like you said, the classic theory will make the correct prediction, and if you use Lorentz transformations, it's only preserved in the rest frame, which, I don't know.
We're saying it's physically valid.
Yeah, we're saying our interpretation is physically valid, whereas you're saying that because it doesn't comport with your mathematical framework, you're not even going to entertain it.
No, I mean, this is a well-tested theory.
The only place you can correct it, well, no, it's kinematically maybe, but dynamically no, because as soon as you change that velocity, you should get a different angle. If we were, okay, pretend there's no water. Pretend there's no water, man. Pretend it's still air. There's no medium change. Let's just say I press a magic button and I slow the light down without introducing water. Because I feel like you're trying to chase a rabbit with this water. The whole point of the water, the only purpose of the water is to
slow down the light. Yeah.
Right. So if I don't even have water there, if it's a vacuum, pretend it's a vacuum, I just press the magic slow down light button and I make it 0.75 C. Would it not still be a different angle? Yes or no?
No, it wouldn't.
It wouldn't.
It wouldn't.
Okay, so if it wasn't a different angle, then what formula am I using? Because now let's make it 0.03 C, right? I've got V over 0.03 C. That does not correctly predict theta. I cannot use stellar aberration formula anymore. I'd have to be using a made-up formula now.
No, you just have to use the formula with C, not with the velocity that you just... I mean, if you slow down the light from the star on the whole path from the star to the telescope, then sure, then you should be using the different velocity of light. But you're only slowing it down at the final stretch in the telescope, and it doesn't matter because it's from the point of view of the telescope, it's already coming from a different direction, and this direction is determined by the velocity that it had.
It does matter because if you see the picture, just look at the picture. Look at the picture I'm streaming right now. You see this purple line right here? This purple line right here?
Yep.
This one. That purple line, the length of that purple line will be different if I change either V or if I change C. If I change either of these two numbers, this purple line changes in size. You can't change these numbers and have the purple line stay the same length. It's literally mathematically impossible.
Yeah, but the problem is you are assuming that the medium that what slows down the light doesn't affect its direction at all. Like you are assuming that it will still be coming down vertically, and the only thing that changes is its speed in the vertical direction, which is not true.
Hold on a second. If the only thing that would cause its direction to change when it passes into the transparent medium would be if it hit at an angle that was not perpendicular, right? That's called refraction. If it's hitting perpendicularly...
Not only that.
Hold on. If it's hitting perpendicularly, refraction does not take place.
No, it's not, of course.
Okay, that's what I'm modeling. This is a zenith star, a photon hitting perpendicularly.
But the thing is, there is another effect at play here. Because, okay, we have a
You
telescope.
can't say that the telescope's
light-
moving and then say this calculation is made in the rest frame, because in the rest frame the telescope's not moving, so then you have no mechanism by which to invoke a moving telescope to create the
Right.
shift. So
Exactly.
you can't have it both ways. You got to pick one or the other.
It's either we're moving or the star is moving, bro. And that's what the water was for, wasn't it? Wasn't it to
Exactly.
settle that
But
question?
there is an incorrect assumption inbuilt in this, because yes, okay, let's have the telescope pointed like this and moving to the side, right? And the starlight is coming from this direction, and then it enters the water. You're assuming that the only thing that will happen is that it will slow down and it will continue vertically. That's a wrong assumption. It's not what is going to happen, because the water will also start dragging the light with it. And we know that precisely.
Yeah, so
Our
that
water's
would be Fresnel drag, and that would predict a 44%
Perhaps.
angle increase. No, not perhaps, experimentally measured and used today. That's not just like it's used in inertial navigation systems to this day, Fresnel drag. So it's a real like phenomenon. So if Earth had that velocity component, the water in the telescope would carry it. That would be, and so you would only be able to explain it through an ether mechanism to carry that velocity component. Additionally, because that's what it was entirely derived under.
Where did I just lost the.
But like we were saying, you have to show something that would show like that the angle either stays the same, because like what's measured is what's predicted if the Earth is stationary, and we use the same aberration angle that you use for air. So like let me show you this quick MMX thing real quick, because this is I think where you might be going wrong here.
Okay, let me just do a quick calculation here, okay? Okay, so I'll just help myself with this. This is y-axis, this is x-axis. Light has speed c. This is v. Okay, so we have light. So in the y direction it is negative c, 0 here, and here it's going to have to be c as well. So gamma v 0. No, wait, this is gamma. And this should be gamma v or negative gamma v, I think negative. We'll see. Okay, 0, 0, 0, 0 times c, 0, negative c equals. So gamma c minus c, so gamma minus 1 c negative, okay, that's correct, gamma v c and negative c. So now the angle here in this frame is, so in the telescope's frame we have this, which is, okay, and speed is, we have to divide this by the other one. So we have gamma v minus 1 c, and in this direction it's 1 over gamma minus 1. Does this make sense? Let me figure this out. Let's see. Gamma squared v squared plus 1. That's v squared over 1 minus v squared plus 1 minus v squared. So, sanity check. V squared plus 1 equals. Huh. Okay, I might have made a mistake. Oh, okay, yeah, I'm an idiot. This is not gamma minus 1, this is gamma. Okay, that's cool.
And thank you for taking the time to talk to us like that. We appreciate it.
Yeah, no worries. Okay. So this is actually, okay. Am I even transforming this correctly? Because I'm starting to wonder.
What happened?
Oh yeah, okay, yeah, that makes sense. So this is this is just V, and this is C divided by gamma. Okay, perfect. Now it makes sense. I'm trying to do the calculations too fast. Okay, now this.
No use
this
of
gets-
ChatGPT now. Just kidding.
Yeah, now this gets slowed down by n, so we have velocity like this, and this gets complicated.
Where are you looking?
Now I'm not sure how to properly transform light moving at the speed. That's not the speed of light. Okay, let's see. So we'll have something negative v over n, negative c over gamma n, and some kind of alpha where squared to no, so minus v squared over n squared minus c squared over gamma squared n squared. This has to be c squared, so alpha squared equals squared plus v squared over n squared plus c. So it's c squared gamma squared n squared plus v squared gamma squared plus c squared over n squared, and that's equal. Those c's will be the death of me. Yeah, I usually work in units where C is 1, and that's getting more intuitive then.
Why don't we just agree that because the Earth's not moving at relativistic speeds in either model, that the correction would be so minute that it wouldn't matter?
Minute, but it's minute, but it's the same order of magnitude of minute as aberration, basically. So that's why it gets important.
No, it's 2 10 millions of smaller. So
not really. So
we showed you it. Like you're calculating it out right now. They agree when you math it out. That's why this is so significant, because the only way that you could, say that there was no actual change is by doing some like bastardized version, of a Lorentz transformation, and not what you're doing right now. Like what you're doing now, you're trying to derive it. But like I'm saying earlier, when you were saying, well, we can transpose the velocity to the star frame and then keep the Earth in motion, but treat it stationary, that would be a violation of Lorentz symmetry, because what you're doing there would also violate aberration in air, which is which this is the issue, right? When you add the water, the angle does increase. Like it has to. Otherwise, relativity would be wrong. Which it is, but we're getting there slowly.
Yeah, I mean, that would suggest that we could put in some super fluid or super sludge that's like a 999 refractive index, and so the speed of light would be 0.001 c, and it would still predict the same angle. That's absurd, right? It wouldn't even reach the eyepiece. It'd like slam into the sidewall at the top of the telescope.
Yeah, because the point is, from the point of view of the telescope, it doesn't matter. Because from the point of view of the telescope, it's just that light is coming from a different direction, and it's not slamming anywhere. It's just coming from this direction and it's slowing down.
Okay. If you move the star, hold on a second, let me ask you a question. I think if we were to take the star from millions of light years away, if we were to literally put the star in contact with the edge of the lens of the telescope, the collecting lens on the far end, if the star was centered on the lens, touching the lens, shining a beam of photons straight down the telescope, right?
Mm-hmm.
And then we hit play, right? We hit play. So then now all of a sudden, it's firing a stream of photons down while the Earth is shifting out from under it. Would there be an angle change? Yes, it would be V over C.
But it was
V over C.
It would be different. Basically, you would stop seeing the star after just a moment.
If it was a single photon, the star, we press play, we let it shoot one photon. If we press play, that photon's going to shoot straight down while the telescope shoots straight sideways, and the angle is going to be V over C. That's what you use. If we put water in it, it's going to be V over 0.75 C. We have a vertical telescope. We have a star directly above it, immediately above it, and we're shooting one photon. What you're saying, basically, if you're saying that's different, right? If you say that's different, which is what you just said, then the only thing that's different is the distance to the star. There's no variable anywhere in any aberration equation for the distance to the star, because the distance to the star does not matter. And the reason it doesn't matter,
that's true,
is because the light is collected at the lens of the telescope. So it doesn't matter how far the photon had to travel to get there. It could have traveled 1 minute, 1 hour, 1 year, 100 million years.
Yeah,
it doesn't matter.
But you still get the correction from the transformation. I mean, it's
you don't have
the distance to the star. Actually, that would be the second derivation I wanted to show you, and the distance to the star would just cancel out, because basically you would have it in two factors, and it would cancel out. So yeah, what you're saying is correct. That the distance to the star doesn't.
Right, it could be any distance. Correct, any distance. So if we use zero distance, it would still work just the same.
Okay, let me try
The reason I'm using zero distance, right, is because it paints the illustration so much better to show how much more absurd your position is. If we just have the star literally at zero distance from the telescope collecting lens, it shoots one photon down the telescope, and at the moment we release the photon, we also push the telescope sideways. It's not going to arrive at the very center. It's going to arrive slightly offset, and we can predict that angle with V over C. Well, if we now increase V, the angle will get smaller. It will get bigger. Sorry. If we increase V, the angle will get bigger. If we decrease C, the angle will get bigger. If we change V or C, the angle will change. You can't change one of the variables and say that the angle wouldn't change. The only thing I changed is the distance to the star from light years away to zero distance, but it just makes it easier to visualize. Because you are claiming aberration happens on the way from the star to Earth's atmosphere. But if that was the case, you'd need a distance variable. I can use zero distance, and there still is the same formula, zero distance, but then you can't say the aberration happens on the way there because it's already there. And in reality, we treat it as already there because we only do the calculation at the moment that the photon enters the telescope anyway.
Sorry, I'm currently focused on this calculation, trying to figure out if I didn't make any mistake.
Yeah, well, you're not just going to hand-wave dismiss everything I said.
Sorry, I'm just... Because I want to arrive at some result.
Does the distance to the star change the angle or not?
Shouldn't.
You said no. So?
No, it shouldn't really.
Right, it doesn't. Right, because it's not a part of any of the formulas. The distance to the star doesn't matter. So if we make the distance to the star 0, we can just treat it as if the only thing we care about is that the moment that the photon enters the telescope, which is what we do anyway. That's how we treat it, actually.
But the thing is, the direction will change because the telescope is moving. That's just what I'm trying to calculate, how the direction changes.
I know it will change, but my point is earlier you tried to tell us that the aberration, it already happens when the light is on its way here. The light is on its way here, it's already aberrated before it gets here. If that was the case, then it would be distance dependent. It is not distance dependent. Therefore, the aberration can't be happening on the way here. It only happens inside the telescope.
Yeah, it's a point of view. I mean, I try to kind of illustrate because the aberration. Okay. The thing is, you get the aberration when you transform. The thing is, you get the different direction the light is coming from when you transform the direction of light to the telescope's frame, and that's regardless. No. But it doesn't matter. I mean, still, from the point of view of the telescope is not moving. So what is interesting to us is what the telescope sees. So we want to transform this whole situation into the telescope's frame. And when we do that, the direction of the incoming light changes. It doesn't matter if it comes from a distance of a millimeter or a light year. The direction will still change. And I'm currently trying to calculate how. I'm getting kind of silly equations, so I might have made a mistake somewhere.
So just a total non-addressing of the fact that at zero distance, you would expect to see an angle change, but you don't see it?
No, you still wouldn't expect the change of angle depending on the medium, because it's still the exact same transformation.
What if we change V? If we change V and we double the speed that the telescope's moving, will that cause an angle change?
Sure.
But if we slow down C, you're saying it doesn't?
Doesn't make
It
sense.
doesn't.
That doesn't make sense.
That doesn't make sense, bro. You can't change changing the numerator will change the answer, but changing the denominator won't.
Because
change any variable, it's going to be
because
a
the speed of the telescope. The speed of the telescope is the only thing that matters for the transformation between the two frames. This is literally the only parameter.
And actually,
the speed of light doesn't enter that.
There's two velocity variables in your equation, actually, there, buddy.
Yeah, but it doesn't enter the transformation between frames, so it doesn't matter. From relativistic point of view, it doesn't matter.
What do you mean?
That's what I'm trying to tell you.
It's not a frame transformation that we're changing. We're literally putting water and slowing it down physically.
Yeah.
It's a physical change.
Yeah, but I mean,
actually,
the speed of light doesn't enter that.
There's two velocity variables in your equation, actually, there, buddy.
Yeah, but it doesn't enter the transformation between frames, so it doesn't matter. From relativistic point of view, it doesn't matter.
What do you mean?
That's what I'm trying to tell you.
It's not a frame transformation that we're changing. We're literally putting water and slowing it down physically.
Yeah.
It's a physical change. Actually,
The speed of light doesn't enter that.
There's two velocity variables in your equation, actually, there, buddy.
Yeah, but it doesn't enter the transformation between frames, so it doesn't matter. From relativistic point of view, it doesn't matter.
What do you mean?
That's what I'm. Because the speed of the telescope. The speed of the telescope is the only thing that matters for the transformation between the two frames. This is literally the only parameter.
And actually,
the speed of light doesn't enter that.
There's two velocity variables in your equation, actually, there, buddy.
Yeah, but it doesn't enter the transformation between frames, so it doesn't matter. From relativistic point of view, it doesn't matter.
What do you mean?
That's what I'm trying to tell you.
It's not a frame there, buddy.
Yeah, but it doesn't enter the transformation between frames, so it doesn't matter. From relativistic point of view, it doesn't matter.
What do you mean?
That's what I'm trying to tell you.
It's not a frame transformation that we're changing. We're literally putting water and slowing it down physically.
Yeah.
It's a physical change.
Yeah, but I mean,
A frame transformation. I don't know if you know this. A frame transformation is not a physical effect. It's all conceptual in your head. It doesn't actually exist. A frame transformation does not physically exist. It's not real.
Of course,
it's just
I agree.
used for your calculation purposes.
Yes,
the only thing
it's
that
used.
matters to matter and energy is physical effects.
Well, can we, real quick,
But
let's go back to basics of piezo and science is out. Real quick. So, wasn't the fundamental reason for putting water in the telescope because it's the way to control a variable in this observation, and then
Correct.
that way,
It's the dependent variable.
right? So, I mean, changing the speed of light because that's what you can do by invoking a medium. That would be the only way to know for sure if the starlight is coming in at an angle because of Earth's velocity, or is it because of the star moving relative to Earth's initial motion? Like, it's not moving. So, like, isn't it just the starlight versus the Earth moving when it comes down to invoking the water as a medium? Isn't that the point of inducing that medium? That's what I'm confused about. Like, where are you going with this?
Point is
that
that
go to church, but you guys finish this up.
I'm just trying to
Your
think, like, what?
cog getting really hard, bro. I just want you to you're literally saying numerator change equals change, denominator change doesn't equal change. Like, that's where you're at
No,
right now.
it's not that's the problem. It's not the denominator. The denominator doesn't change because it's not the velocity of light in the medium. The denominator is just c. That's it. It doesn't change between those because it doesn't enter the speed of light in the telescope doesn't enter the equation at all. That c that appears there comes from the transformation between frames.
But that's why they put water in the telescope, because it does change c.
No, because they predicted that it would because they used the ether theory. But according to relativity, it does not. That's the issue. So the final result from relativity is different because from relativistic point of view, that's what I'm.
2 10 millionths.
No, not at all. It's completely different. Like
classic derivation versus the relativistic derivation is off by.
But you're still still substituting the speed of light in the water instead of speed of light in the vacuum. It's not the relativistic prediction that you're comparing. The relativistic prediction uses c, just c, the constant c, not the c, not the speed of light in the medium.
But physically speaking, in the real world, putting water in a telescope does affect the way the light comes in. That was the point of putting water in the telescope. Why would Airy do that?
But it
otherwise?
doesn't. Because
does,
the
are you saying Snell's law is wrong?
No. Now you're mixing different things. In Airy's time, there was no relativity. He wasn't testing relativity. He was testing an ether theory. So according to an ether theory, that would affect stuff because the speed of light in the telescope does come into the prediction of an ether theory. But it does not come into the prediction of relativity because relativity doesn't care what happens there because the transformation of the direction does not depend on the speed of light in the medium. It only depends on the speed of the observer. So when the observer is basically when the observer moves at v, only this v enters the equation, and the transformation uses c, the speed of light in the vacuum, and there is no speed of light in the medium in the telescope anywhere in the derivation. So this whole tangent theta equals v over c, this c is always c, the constant c
That's
in
cool.
relativity.
That's cool in math, bro. But like literally, water changes the speed of light.
Sure, it does, but it doesn't matter
Okay.
for this experiment.
That's
From the
cool,
point of
then
view of
why would you put
relativity.
water in the telescope? That makes no sense, bro. Like,
Because it doesn't matter from the point of relativity, but he didn't know that because he didn't know relativity, because it wasn't a thing back then.
why even invoke relativity? What's in question is, does the starlight come in at an angle because of Earth's velocity, or
Sure.
is it because the
It
star
does.
is moving?
But that's equivalent. From the point of relativity, there is no difference.
Exactly. So, hence the water. That was the point of putting water in the telescope, because you can make a kinematic equivalence between the starlight moving versus the Earth stationary, and the Earth moving versus
No.
the star
Yeah.
coming in at an angle.
So
Yeah.
the point of the water was that in ether theory there would be a difference if the star is moving or if the Earth is moving.
Doesn't matter
No,
about the ether.
no. Listen, let me show you this real quick before we wrap this up, because this is independent. If the Earth is moving, that's a dynamic effect. It doesn't matter, like relativity. Oh, it's not absolute. It doesn't matter. Yes, when you introduce water, that purple line that PZL was showing you has to change. Doesn't matter what theory you believe in. If the Earth is actually in motion, it doesn't matter if you philosophically think that you could treat it, due to reference frame transformations, blah, blah, blah. If it's actually in motion, the point of adding the water was that the angle would increase. Both theories, classical and relativistic, you just try to derive it, make the same exact prediction.
And it's only off by 10
And
millionths.
And they measure no change. The implication is that the Earth is stationary and the starlight is what's coming in with that horizontal velocity component.
Correct.
That's not the correct conclusion.
Why?
It's the only conclusion. You cannot
No.
show me a formula that shows that in water it will make the same prediction. It's not possible. You've been trying. It's not. There is none.
No.
The reason why you're having such a difficult
basically-
time is
no.
because it doesn't work in relativistic
No,
paradigm.
it does work. It does work. That's the thing. Because I was already saying, basically, from the point of relativity, anything you are saying doesn't matter because you're just transforming the direction. So there is you just get this direction of light in this frame is this. You transform
Okay.
it.
And if you did
and
that,
this angle depends only on v. It does not depend on the speed of light in the telescope. That's it.
it's precisely okay. Listen,
That's why it doesn't change, because from the point of relativity, you cannot say that the Earth is moving or that the star is moving. It's all the same. So from the point of from the point of view of relativity,
is invalid.
it's all the same.
Relativity.
No, it's perfectly valid.
No, nope. The only theory that makes the correct prediction with what's measured is a stationary Earth with respect to
That's not true.
with the sky in motion. Yeah, you
That's
can't.
not true at all.
Bro, you can't show me a single transformation that predicts the same thing. Math it out.
That's what I was trying to do here. Basically, okay, that is
You were doing the math that we
one of
already did.
yeah. One of the transformations actually already did. So basically, this speed of light here would be v, here would be 1 over gamma, and then the tangent of
I got an
this
idea of science. I got an idea.
angle
Look at the
angle
math.
theta,
Look at the math that Alan provides you. Right. Go ahead and
c
show
over
real quick.
gamma,
But just check
gamma
it
v
out.
over c. That's it.
I want you to check his math and see if it is in the same vein that you're trying to go down to save you some time. And then if
Okay,
there's something
where?
wrong, you point it out. Yeah, let him show it to you. I think it would be better that way.
Get you the link in 1 sec.
Only because we went through this, you know what I mean? So it'd be good to if there's something wrong in the relativistic derivation that we uncovered, then point it out. But if not, then you'll understand the position a little more. I appreciate you coming on though, bro. Seriously.
No worries.
This is what we're here for this kind of discussion, so.
Oh yeah, okay. Because
There you
this
go.
also uses this cosine. Yep.
Yeah, and then see if there's anything wrong with that derivation,
Okay.
that explanation. Yep.
But I'm not saying that there is anything wrong with this derivation. But you may have noticed that it doesn't mention any speed of light in the medium anywhere at all. C is just the speed of light in the vacuum.
It's just a ratio of velocities, bro.
No.
Yeah, that's all it's ever been. Listen,
not.
and the reason that it makes the correct prediction is because this is the evidence for the ether framework. You can measure velocities relative to the ether framework. This is the only thing that makes the correct prediction is the Earth being stationary.
Okay.
Yeah.
Your argument against relativity is that if you substitute for c the speed of light in water, if the water is in the telescope, then you are getting the wrong result. So you are getting a result that is not observed in reality. But relativity doesn't tell you to put the speed of light in water in this formula. In this formula, this should be c, regardless of what is in the telescope.
Are you
So
aware
you
that
are-
relativity uses velocity composition, plus or minus c to answer Fresnel drag? So what you're saying it's contradictory
don't
to
know.
other parts of relativity.
Not at all.
Then yeah,
I think you
Not at all.
should show him that.
he just agreed. He knows.
That's basically what I'm currently trying to derive to
Okay.
show you what happens.
So what you would
From the point of
okay,
view.
Okay, can we agree then, right? If you're trying to derive something with Fresnel drag, that the angle is going to increase by 44% at least of the 27.5.
I'm not sure yet.
But just doing it off the top of the dome, right? Like we know that Fresnel drag will carry 44% of the velocity potential in the direction of motion. So so the angle, so if there was no Fresnel drag and we were just doing it off of the angle, it would be 27.5 arc seconds in water. But if we Fresnel drag it, it would be 44% of that, right?
Wait.
So it still has to increase though. That's the thing I'm saying. You're not going to show me a formula that predicts the same angle with a variance in the speed, because that purple line that PCO was showing you, if the Earth is actually in motion, is going to change, which is going to result in the effect. The purpose of the experiment, as stated by Klinkerfuse in the opener to his paper, which is the prelude to Airy doing his experiment, because this guy said that he actually measured the angle increase. And Airy was like, okay, let me confirm that, because that's crazy. That would be a great confirmation that the Earth is in motion. And what he's describing at the beginning of his paper, he's like, look, the aberration, can be an apparent effect, and it can also be a real effect. And to distinguish the difference, we have to manipulate one of these variables. And because the Earth's always in motion, all we can do is change the speed of light. That was the whole hypothesis of it. And he goes on to talk a little bit about how this experiment is so cool because it's independent of ether as like a fluid medium mechanism, and they can just treat it as the V over C, Snell's law, and cosines to derive the angle. And there's no like ether mechanisms effect at play to they have to be accounted for, but they should consider possibly Fresnel drag because that was experimentally verified, stuff like that. So he says don't fully discount it, but in his derivation and what he's proposed and what agrees with actual measurement is the classical derivation just using Snell's law and cosines. So
I mean, that was like the whole,
like that was the
point.
purpose.
Right. Klinkerfuse is like, yo, check this out. Airy's like, no way, let me see. And then what? Science, it's perfectly okay to just accept that the Earth is stationary, bro. No one will hate you for it.
No,
except we know it's not. Okay.
I mean, we're looking at the complete loss of aberration here.
No one will hate you for it.
No,
except we know it's not.
Science, it's perfectly okay to just accept that the Earth is stationary, bro. No one will hate you for it.
no,
except we know it's not. Okay.
Science, it's perfectly okay to just accept that the Earth is stationary, bro. No one will hate you for it.
no,
except we know it's not.
And what? Science, it's perfectly okay to just accept that the Earth is stationary, bro. No one will hate you for it.
no,
except we know it's not.
And what? Science, it's perfectly okay to just accept that the Earth is stationary, bro. No one will hate you for it.
no.
except we know it's not. Okay.
I mean, we're looking at the complete loss of aberration here, which would be the only actual ratio that gives 30 kilometers a second.
Okay, if I didn't make any mistake here, which I cannot guarantee, it means that what happens? Let me just cut this and paste it in a new page. That if we have a telescope where there is light entering at C from vertically, and the telescope is moving at V, once the light enters the telescope, it will no longer be moving at C vertically. It will be moving at this speed vertically. So once it enters, it will have velocity like this, with this component Vx and this component Vy. Okay, maybe V was not the best choice. So let's call it C prime X and C prime Y, and this should also say C prime and C prime. Okay, yeah, this should be plus in this case. Okay, so for water, if n is, what's n for water, like 4/3, right? Yeah, I think that's what we use.
Yep.
So we have 69, so square root of n squared plus 1, for if n is equal 4/3, this square root is, this is 5/3, minus 1, so that's 2/3, and this is 5/3. Okay, this should be v squared over c squared, this should be v squared over c squared, and this should be times c, and this should be, okay, this is v, okay, because I was using the units where c equals 1. So we will have something like c prime x equals 2/3 v divided by 5/3 minus v squared over c squared, and c prime y equal c over gamma squared 5/3 minus v squared over c squared, if I didn't make any mistakes, which, as I said, I cannot guarantee. So basically, if this is much less than 1, which it is for the case of the Earth, this is basically 5/3. So we have 5/3, and so we have like 2/5 of v, and here we have like 3/5. Huh? Okay, I must have made a mistake somewhere because this doesn't make sense. Over gamma squared, no, yeah, that doesn't make sense. This should be closer to 3/4. So I made a mistake somewhere. But yeah, but basically you get this speed horizontally. What, did I make a mistake?
So if you get any other output other than 27.5 arc seconds, it's incorrect.
No.
Yeah.
So that's the
No, but
same.
the thing is-
That's the same velocity composition that's actually used.
But what I'm trying to say is basically you cannot assume that once the light enters water looking from the external frame, so we are here looking from the, let's say, sun's frame, where the telescope is moving at v to the side, you cannot assume that the light will proceed vertically. It won't. It will turn. And because it will turn, the time the light takes to get to the bottom will increase, but it will not go directly vertically, so we will not get this deflection by this factor of v over c prime. But basically this will be like 3/5 of v over. Oh, that's actually pretty cool. Over 3/5 of c over gamma squared. So that gives something like gamma squared v over c. So perfect, because this still is v over c.
So what's
C, not C prime.
So what's the actual angle increase that you predict out of this?
Basically the same. But for some reason I got gamma squared here.
Wait.
But yeah, but basically because
you
this
predict 27.5 as well.
So, no, not 27.5. See, there is still v over c squared, and that's the. Okay.
Yeah. That's my whole point. The gamma term, right?
Basically, you will
Takes
get
it-
something like gamma
it
squared
take-
v over c.
Right.
I don't.
Can you hear me?
Yeah.
Listen, that's my whole point. It agrees with the classic derivation up to 2/10 millionths of a degree.
No.
Nobody can measure that difference in the deviation. So for all intents and purposes, the classic
No, see-
version and the relativistic version are the same.
But see, there's c here, not c prime. So it's the speed of light in the vacuum. So still, you get like 30 kilometers per second over
So no
Over three.
aberration.
100,000 kilometers per second tangent of theta. So that's like 1
No
over
aberration if you go 30
10,000.
kilometers.
So 1 over 10,000 of, so basically theta is something like 0.1 milliradians, whatever this is. Let's see. Fuck. Wait, not.
Sorry, bro. Water in a telescope destroyed relativity. It's cool.
Increase point. Wait, 0, yeah, that is 0.1 milliradians times 3600. Yeah, that's 20.6 arc seconds.
How many did you say it was?
20.6.
Okay.
Anyway, I'm kind of skeptical about this.
Yeah.
Oh,
So
no.
so one of the velocity components that you changed was the velocity of Earth in one of these transformations here.
Not really. So what changed here is that the
only
light
way you could
entering
do
the
it.
telescope, the light entering the telescope gets about 40% of velocity of Earth to the side. So I believe that's what you were calling the Fresnel drag. So that's the velocity here, and because of that, it will actually get deflected by a different amount. So basically,
Go ahead.
So because of that, because it gets this like 40% of the velocity of Earth here from the point of view of the telescope, it's only deflected by like
Okay. So
basically you have a different value in the denominator. But
what you're
I'm
doing,
skeptical because it's 3/5 and not 3/4 as I would expect. So I probably made some mistake.
what you're doing still contradicts aberration in air then. Like you can't do this where you have this horizontal velocity component, you make the Earth stationary, but then you still treat it as moving to keep the effect to be the same. Like, dude, you can't.
No, what I was just trying to do.
No, I see what you did. What you did is you essentially changed the velocity of Earth to compensate it.
No, I
That's-
didn't
yeah,
change the
that's-
velocity of Earth.
Yeah.
No. What I did was I calculated how the velocity of light as a vector would change upon entering the medium, because it would change, because basically the moment the light enters the medium that is moving to the side, it gets dragged by the medium. So that changes the velocity of light. And because it changes the direction in which the light is moving, and because of that, the deflection that you get relative to the center of the telescope is no longer v over c prime, but it's like this v minus this over this. But I don't trust those results. I think I made a mistake somewhere in the derivation. But anyway, the end result I got was still like v over c and not v over c prime, which you guys are claiming. That's the thing. Because there is this dragging, which you don't take into account when you are looking at it from the outside. And the easiest way to just disregard all of this and forget that this happens and not even not get dragged into those calculations is just to look at everything from the frame of reference of the telescope from the start. The telescope treated the telescope as stationary, transform everything into this frame, and you get exactly the same result. You get exactly not exactly because the gamma enters there, but you get like this tangent theta equals gamma v over c.
And this is the
And
last
that's-
time I'm going to repeat it though, before we wrap up, because you're kind of just saying the same thing over and over again. The formula on Wikipedia that they use gives 27.5 arc seconds. It's
It does
using
not, because-
it's using the actual velocity composition. What you're doing is transposing.
You are misusing the formula.
Dude.
You are inputting 0.75c instead of c. The formula
Hold on,
says c, and it says c for a reason.
Let him finish, bro.
Bro,
Just let him
You're transposing the velocity and saying that it's being, oh, well, it's carrying it in the same direction too, therefore there's not going to be a change. That's a huge mathematical assertion that contradicts the actual velocity composition. This is a custom interpretation you're doing
This
here.
is this is derived with the velocity composition. I just used the velocity composition to derive this result.
Dude, they agree up to 27.5 arc seconds if you do it right. So your assertion about dragging it and keeping that velocity component in there is wrong. That is what is contradicting you with air. Yes, because you can't have it in both ways, man. This is the issue.
That's the thing. In both cases, you should use c, the value in vacuum, not the value in the medium. Both in the case of air, in the case of water, in the case of vacuum. That formula says c, not c in the medium, and it says it for a reason. And that reason is because it's not derived the way you think it is derived. It does not care about what the velocity of light is in the telescope. It only cares about how the direction of light transforms, and that uses c regardless of what happens in the telescope.
It's a ratio of velocities. You have to assume a ratio. You have to assume a velocity and then transpose it, which contradicts the velocity in air, dude.
It does not come from the ratio of the velocities. That's where you're wrong. That's what I was.
30 kilometers over 300 million kilometers.
It's
That's a ratio,
only
bro.
superficial.
It's v over c.
Sure, but it's not the ratio of velocity of the Earth to the velocity of the light in the telescope. It's the ratio of the velocity of the Earth to the speed of light in the vacuum. C. No matter what is in the telescope, there should be C.
And you know, okay, and you know what creates that difference, dude? There's a timing difference, right? So when you slow down light, yeah, that's what allows the angle to increase, dude.
Only in the ether theories.
No, in any theory, dude. In any theory, you cannot listen. You cannot say, oh, only in the ether theory, but use V over C in air. That is the ether theory, right? And then when you don't get the measurement in water, you're like, oh, we'll just assume the velocity and transpose it under transformation. Dude, you're looking at it. You're doing, yeah.
No, what I was just doing was to basically compute what's happening to the light when it enters a moving medium. So because it has to be dragged, so I was trying to derive this dragging, that's all. But you could not do all of this. You could just do what I was talking from the beginning. You could just take the direction of light, transform it into the frame of the telescope, and you will get the correct result every time, because the transformation does not care for the velocity of light inside the telescope. It only uses c as the speed of light in the vacuum, because the c there comes from the Lorentz transformation, not from the speed of light in the telescope, not from any timing, not from anything like that.
If you use any other,
relativity.
if your calculation doesn't agree with the classical velocity composition, the way that it does when you do it correctly, then down to 2/10 millionths of a degree,
but you are doing it
then you're contradicting air, dude. You're doing a roundabout way to keep the velocity imposed, which would contradict air. Yeah, you keep saying no, man. I'm done. I can't continue it anymore.
Because you keep saying wrong things. You are telling me what I'm doing when I'm not doing it.
If the Earth is in motion,
hang on, guys. I would go one at a time, and even if someone is saying wrong things, it's really frustrating if someone's like in the middle of speaking and you're just chiming in like, no, that's not true, right? Like, even if he is wrong, I would just give him time to finish it and then, respond.
Fair enough.
Yeah, I think this egg has been cooked.
yeah, we're just going back and forth in circles now.
True.